We have equation given to us in polar coordinates, and we want to rewrite the equation in the rectangular coordinates, and we want to identify the curve. So if we have equation that equals to pi over 4, firstly, I can sketch it. So direction is always pi over 4. And I sketch a graph. And we kind of see a straight line through our origin. Now let's confirm our findings by doing algebra. So we recall that tangent theta equals to y over x. Theta is in our case fixed, equals to pi over 4. So we have tangent pi over 4 equals to y over x. Tangent pi over 4 is 1, so we get 1 equals to y over x. Multiply both sides by x, we get x equals to y. And we identify a straight line from origin y equals x. Second equation, we have r equals to 4. Then we recall that r squared equals to x squared plus y squared. So we start with r equals to 4. We want to get r squared, so we square both sides. So we're going to get r squared equals to 16. Using the formula that r squared equals to x squared plus y squared, so we have x squared plus y squared equals to 16. And recognize that as a circle of radius 4, center at the origin. Next one. If we have curve given to us by polar r equals to 4 sine theta, then looking at the list of formulas which you know how to relate polar and rectangular, then we recall that one of them is saying that y equals to r sine theta, and we already have sine theta, so we wish to have r sine theta, so multiply both sides by r. So on the left side we're going to get r squared, and on the right side 4r sine theta. R sine theta is y. R squared is x squared plus y squared. Now we move everything on one side, so we get x squared plus y squared minus 4y equals to 0. We complete square by adding half of coefficient of y, which is minus 2, so minus 2 squared is 4 to both sides. So we get x squared plus y minus 2 squared equals to 4, and recognize that as a circle of radius 2, center 0 and 2. In the next example, we want to sketch a graph of polar curve r equals to theta when theta is greater or equal than 0. So to sketch a graph, what we'll do is we'll start doing it by points. So points. We're going to choose theta, and we're going to find corresponding r. So if theta equals to 0, r equals to 0. If theta equals to pi over 2, r equals to pi over 2. If theta equals to pi, r equals to pi, 3 pi over 2, and 3 pi over 2, 2 pi, and 2 pi. Usually we do at least one rotation, just to see what is going on. And now we transfer these points on our xy plane. So we start when r equals to 0 and theta equals to 0. When angle equals to pi over 2, so we're on a positive y-axis, r equals to pi over 2, so we get point somewhere here, pi over 2. When we have angle equals to pi, when angle equals to pi, radius is also pi, so we know distance pi from origin, so we're somewhere here, distance pi, so it's negative pi on x-axis. Then angle is 3 pi over 2. We are negative part of y-axis, so angle is 3 pi over 2. R is 3 pi over 2, so it's negative 3 pi over 2. And when angle is 2 pi, we're back to positive x-axis, and then here we have to mark distance 2, so get 2 pi. And now we'll connect smooth curve through the given points. So we start at the first point and go to the next, go to the next, to the next, to the next, and hopefully we'll see kind of spiral, something like that. Sketch the graph of r equals 2 plus 2 cosine theta. Firstly, I'll sketch a graph on r theta plane. So because we have 2 plus 2 cosine theta, we know it's going to be between 0 and 2. So between 0 and 2. So cosine starts at the max. So we'll start at 4. Average is 2. And because it's cosine, we start at top. So I will draw one period, and then it starts repeating itself if you want. Then it's 2 pi here, pi here, pi over 2, and 3 pi over 2. Okay. Now I transfer that graph on xy plane. I start when angle equals to 0. When angle equals to 0, theta equals to 0, r equals to 4. That's my first point. Second point, when angle equals to pi over 2, r equals to 2. So somewhere here, r equals to 2. Distance from origin is 2. When angle equals to pi, distance equals to 0. So we are at origin. So our next point is here. Next point is when angle equals to 3 pi over 2. So we are on the negative part of y-axis. Then distance we should measure is 2, so measure 2 units in this direction. We're here. That's the next point. And the last point is when angle equals to 2 pi, distance is 4, so we're back to square 1. So now we connect our points through a smooth curve. And we're going to get curve which looks like this, and that curve is going to be called cardioid. Cardioid along x-axis. Next example, you want to sketch a graph of r equals, say, 4 plus 2 sine theta. We'll start doing the same thing as we did before. We sketch a graph on r theta plane. And you see, because we have 4 plus 2 sine theta, then r will be between 4 plus 2 is 6, and 4 minus 2 is 2, so it's going to be between 2 and 6. average is going to be 4. And because we're drawing the graph of sine starts in the middle and it's going up and down and up, and we're doing only one period. We can continue. So now we're going to mark the points. 2 pi here, pi over 2, 3 pi over 2. And we can sketch the graph on xy plane. So we start at a point and theta equals to 0, r equals to 4. Next point is on y-axis is going to be 6. Somewhere here. Next point on pi, when angle equals to pi, negative y-axis is 4. And then 3 pi over 2 it's 2. And 2 pi back to 4. So we're going to sketch our curve, which is going to look something like this. So that's how curve is going to look like, and that is so-called limmason. One more curve to sketch, r equals to 2 plus 4 sine theta. So as usually we do, we start with r theta. 2 plus 4 is 6. 2 minus 4 is minus 2. Average is 2. Because we're doing sine equals starts at the middle, and I'm sketching only one period. It looks like this. 2 pi here, pi here, 3 pi over 2 here, and pi over 2 is here. And also in that graph we have point of interest, these 2 more points, when r equals to 0. So when r equals to 0, we have 2 plus 4 sine theta equals to 0. So 4 sine theta equals to negative 2. So sine theta equals to negative 1/2. So theta equals sine theta equals to 1/2 when the angle equals to pi over 6. So our reference angle is pi over 6, so it's pi over 6 plus pi, or 2 pi minus pi over 6, which is 7 pi over 6 and 11 pi over 6. So these 2 points r equals to 0. Okay, so let's sketch the graph now. Let's mark our points. First point, theta equals to 0, r equals to 2. Next point, pi over 2 and 6. 1, 2, 3, 4, 5, 6. Next point, pi and 2. 1 and 2. Next point, we're going to hit origin. Next point, 3 pi over 2 and negative 1. So we're supposed to be going 3 pi over 2 direction, but negative 1 unit in that one, so we are here. Next point, origin again. Next point is 2 pi. 2 pi is 2 back here. So point 1, 2, 3, 4, 5, point 6 back to the origin, and last one, 0.7 here. So now connect 1 to 2, 2 to 3, and so on. So I'm going to get something like 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and to 7. So we're going to get graph which looks like this. That is so-called Limason with inner loop. In general, when we have polar function given to us r equals a plus a cosine theta, or a plus a plus sine theta, those are going to be cardioids. Similar to the graph which we just did earlier, so it's going to be either along x-axis or along y-axis. So it might look something like this. It will barely touch origin and then turn around and make something which looks like a circle along x-axis or along y-axis, and maybe flip to the other side. Another possibility is r equals to a plus b cosine theta, r equals to a plus b sine theta. Here we assume that both a and b are positive, and if a is bigger than b, bigger than 0, then we're going to add Limason. And the graph of Limason is gonna look like we start somewhere, then we go around origin without touching it, and at some point it bends toward it. And again, the graph might be along x-axis or maybe along y-axis. It might be flipped. That's Limason. That's the case when a is bigger than b. And the last case is when we have r equals to a plus b cosine theta, or r equals to a plus b sine theta, when we have a is less than b and both are positive. In this case we're going to get Limason with inner loop. That's the last graph we just did recently. So the picture might look like this. So we pass through origin, we go inside, when we get inner loop, and we're going to get outside. So Limason with inner loop.